In this section, we will be covering the following: air brake system parts, dual air brake systems, inspecting air brakes, using air brakes. Hydraulic brakes require either oil or hydraulic fuel to operate. They are housed in a container called the master cylinder. When the brake pedal is pressed, a force is transmitted immediately and directly at each wheel to help the vehicle slow down. This system is usually found on smaller vehicles. Hydraulic systems with ABS will stop in shorter distances than comparable air brake systems. Air brakes use compressed air to slow your vehicle down and bring it to a stop. When the brake pedal is pressed, air flows through the brake lines and apply the brakes at each wheel. There is a split-second delay in brake reaction from the moment you apply or release the brake pedal until your vehicle stops. But air brakes are better at stopping larger vehicles than hydraulic brakes. When driving air brake vehicles, there is an added delay. This is called brake lag. This is the time required for the brakes to work after the brake pedal is pushed. With hydraulic brakes, the brakes work instantly. However, with air brakes, it takes a little time for the air to flow through the lines to the brakes. This makes the total stopping distance longer for air brake vehicles than for hydraulic brake vehicles. Causes of brake lag. The brakes may be wet during heavy rain. When traveling downhill, the brakes may become very hot. Effects of brake lag. Brake lag may increase your total stopping distance by 32 feet in good weather. When you start your vehicle, your ABS light will come on and your air pressure will start to rise. The air governor will tell the compressor when it should start pumping air into the tanks. This should happen when the PSI reaches 125. At this point, you will hear a loud noise and the compressor will stop pumping air into the tanks. This is called the governor cutout. The air compressor is connected to the engine through gears or a V-belt. The job of the air compressor is to pump air into the air storage tanks. It may be cooled by air or the engine cooling system. You should check the oil level before driving. The air storage tanks. They store compressed air for regular use during braking. Every time you push down on your service brake, air is retrieved from the tanks and then replaced by the compressor. There is a reserve of air in your tanks to stop your vehicle safely. They hold enough air to allow the brakes to be used several times. Dual air brakes. Dual air brakes have two separate air brake systems that use one single set of brake controls. Each system has its own air tank, hoses, and line. One system operates the brakes on the rear axle and the other operates the brakes on the front axle. The first system is called the primary and the other is called the secondary. If one of the systems is very low on air pressure, either the front or the rear brakes will not be operating fully. If you see this happen, you must bring your vehicle to a complete stop and have the problem fixed. While driving vehicles with air brakes, you must perform maintenance to ensure their safe operation. Compressed air may have water and oil in it, which may be bad for the air brake system. Therefore, you should drain the storage tanks every day after driving, because water can freeze in cold weather and cause brake failure. Check the level of your alcohol evaporator. This will greatly reduce the risk of ice in the brake valves and other parts during cold weather. Alcohol freezes at negative 185 degrees Fahrenheit. Gauges. There are two types of gauges on air brake vehicles. One is mandatory, the other is not. Supply pressure gauge. Any vehicle that uses air brake systems must have a supply pressure gauge connected to the air tank. If you have a dual air brake system, there will be a gauge for each half of the system, or a single gauge with two needles. When you are driving and press down on the service brakes, it will tell you how much air is available for safely stopping the vehicle. If you start to run low on air pressure, you may have to stop the vehicle. Application gauge. The application gauge is not required to be on all vehicles. When you put your foot down on the brake pedal or your service brake, it tells you how much air is being applied to your service brakes. The brake pedal is used to stop the vehicle. After you press down on the brakes, you come to a stop. It is also called the foot valve or treadle valve. The harder you press down on the brake pedal, the more air pressure is released. Once you take your foot off the brake pedal, it will release the brakes. This will cause the air pressure in the tanks to drop. This lost air pressure must be made up by the air compressor. If you press down and release the brake pedal unnecessarily, this can let air out faster than the compressor can replace. If the pressure gets too low, the brakes won't work. Drivers behind you must be warned when you put on your brakes. The air brake system does this with an electric switch that works by air pressure. The switch turns on the brake lights when you put on the air brakes, letting other vehicles behind you know that you are going to stop or slow down. In newer vehicles with air brakes, you put on the parking brakes by using a diamond-shaped yellow push-pull control knob. On older vehicles, the parking brakes may be controlled by a lever. It may be a round blue knob or some other shape. This also could be a lever that swings from side to side or up and down. To activate the parking brakes, pull the knob out. To release the parking brakes, push the knob in. Always use the parking brakes whenever you park, because your vehicle may roll away. When driving a combination vehicle, if your trailer doesn't have spring brakes, you should always chock the wheels. Caution: do not use the parking brakes if they are very hot. Do not use them because they can be damaged by the heat. Let them cool off before using the parking brakes. Don't use the parking brakes if they are wet in freezing temperatures. Freezing temperatures can freeze the parking brake so the wheel cannot move. If the brakes are wet, use the brakes lightly while driving in low gear to heat them up and dry them off. The dual parking control valve. If for some reason there's a defect in the air tanks, your emergency spring brake may come on to the out or lock position. Some vehicles, such as buses, may have a separate air tank which can release the spring brakes. This is so you can move the vehicle in an emergency. When you push the control valve, the spring brakes come on again. This permits air from a separate air tank to release the spring brakes so you can move a short distance. There is only enough air in a separate tank to do this a few times. You should plan carefully when moving. Otherwise, you may be stopped in a dangerous location when the separate air supply runs out. All trucks, truck tractors, and buses must be equipped with emergency brakes and parking brakes. They must be held on by a mechanical force. When driving, powerful springs are held back by air pressure. If the air pressure is removed, the springs put on the brakes. Combination vehicles. A parking brake control in the cab allows the driver to let the air out of the spring brakes. This lets the springs put on the brakes. A leak in the air brake system, which causes all the air to be lost, will also cause the spring brakes to put on the brakes. Tractor and straight truck spring brakes will fully come on when the air pressure drops to a range of 20 to 45 psi. Caution: never push the brake pedal down when the spring brakes are on. If you do, the brakes could be damaged by the combined forces of the springs and the air pressure. Many brake systems are designed so this will not happen. Do not wait for the brakes to come on automatically. Warning signs: when the low air pressure warning light and buzzer first come on, bring the vehicle to a safe stop right away, while you can still use the brakes. Brake failure: the braking power of spring brakes depends on the brakes being in adjustment. If the brakes are not adjusted properly, neither the regular brakes nor the emergency parking brakes will work. Excessive heat may also cause brake failure. Modulating control valves. In some vehicles, a control handle on the dashboard may be used to apply the spring brakes gradually. It is spring-loaded, so you have a feel for the braking action. The more you move the control lever, the harder the spring brakes come on. They work this way so you can control the spring brakes if the service brakes fail. When parking a vehicle with a modulating control valve, move the lever as far as it will go and hold it in place with the locking device. Some older vehicles made before 1975 have a front brake limiting valve and a control in the cab. The control is usually marked normal and slippery. Limiting valves were used to reduce the chance of the front wheels skidding on slippery surfaces. However, they reduce the stopping power of the vehicle. Make sure the control is in the normal position to have normal stopping power. When you put the control in the slippery position, the limiting valve cuts the normal air pressure to the front brakes by half. Front wheel braking is good under all conditions. This test has shown front wheel skids from braking are not likely even on ice. Many vehicles have automatic front wheel limiting valves. These valves cannot be controlled by the driver. Foundation brakes. Foundation brakes are used at each wheel. The most common type is the S-cam drum brake. Brake drums are located on each end of the vehicle's axles. The wheels are bolted to the drums. The braking mechanism is inside of the drum. To stop, the brake shoes and linings are pushed against the inside of the brake drum. This causes friction, creating heat, which slows the vehicle down. Caution: when you use the brakes for a long period of time or push down hard on them, the excess of heat can cause the brakes to stop working. How the S-cam brakes work. When you push the brake pedal down, air is let into each brake chamber. Then the air pressure pushes a rod out and moves the slack adjuster. The movement twists the brake camshaft. This turns the S-cam. The S-cam forces the brake shoes away from one another. When you release the brake pedal, the S-cam rotates back and releases the brake shoes. These are all the steps that create the stopping action in the S-cam braking system. When you turn your vehicle on, your air pressure gauge will start to rise. Upon reaching 125 psi, the governor will cut out. At this point, the compressor will stop pumping air into the storage tanks, and you may hear a loud sound. Once this happens, no more air will be pumped into the air tanks. Every time you use your brakes, air is released from the air tanks. When the pressure in your tanks drops below 100 psi, the governor will tell the compressor to stop pumping air. This is called the governor cut-in. There is a risk of having too much pressure in the air tanks. When your air pressure rises above 150 psi, there is a safety mechanism that will automatically cut off the air pressure to prevent damage to the air tanks. This is called the safety valve. If the governor does not cut off the air pressure, the safety valve will. If there is a defect in the air brakes and the air pressure drops below 60 psi, you will see a low air pressure warning light come on. This light will warn you with a buzzer and a flashing red light. If this happens, you must bring your vehicle to a stop. When the air pressure drops below 20 to 45 psi, the emergency spring brakes will come on. These powerful springs, which are held back by air pressure, will lock your wheels and you will not be able to move the vehicle. At this point, the only way to move your vehicle is if the air pressure rises above 45 psi or your vehicle is towed. The slack adjuster test. This test is used to manually check the adjustment of the brakes. To test the slack adjuster, park on level ground, release the parking brakes, chock the wheels, and use a glove and pull hard on it. The slack adjuster should not move more than 1 inch. The brake drums are located on each end of the vehicle's axles. The wheels are bolted to the drums and the braking mechanism is inside of the brake drum. During the vehicle inspection, make sure that the brakes are properly adjusted. The brake drums should not have cracks more than half the width of the friction area. The brake shoes. To stop, the brake shoes are pushed against the inside of the brake drum. This causes friction that creates heat, which slows the vehicle down. The brake shoes must not be worn dangerously thin. They should not have any kind of oil, grease, or brake fluid on them. Caution: do not brake too fast or too hard. Otherwise, your brakes may heat up and reduce their braking power or stop working. The braking power will always depend on the brakes being in adjustment. If your brakes get out of adjustment, braking might be affected. Pumping by the air compressor should start at about 100 psi and stop at about 125 psi. To test the air governor cutout, turn on the vehicle and wait for the compressor to start pumping air. Observe that the pressure gauge should rise to 125 psi. Once the air pressure stops rising, you will hear a loud noise. To test the air governor cut-in, the engine should be idling. Step on and off the brake pedal to reduce the air tank pressure. Observe the air pressure gauge. Once the air pressure drops to 100 psi, the governor will start pumping air again. If the air governor doesn't work, it may need to be fixed. Air leakage test. To make sure your air brakes are safe to use, you must perform an air leakage test. This test may be performed with your foot on or off the brake pedal. There will be a different result for both tests. There are 2 things you need to know before you perform this test. You should know if your foot will be on or off the brake pedal. You should know the type of vehicle that you are driving. To perform the test, make sure you have enough air pressure, at least 125 psi. Chock the wheels. This will prevent movement during testing. Turn off your engine and release the parking brake. Count for 1 minute. Observe the needles on your gauges with your foot off the brakes. If you are driving a straight truck or bus and your foot is off the brake pedal, you should not lose more than 2 psi in 1 minute. If you are driving a combination vehicle, you should not lose more than 3 psi in 1 minute with your foot on the brakes. If you are driving a straight truck or bus and your foot is on the brake pedal, you should not lose more than 3 psi in 1 minute. If you are driving a combination vehicle, you should not lose more than 4 psi in 1 minute. If the air loss rate is too much, check for air leaks and have them fixed before driving the vehicle. Otherwise, you could lose your brakes while driving. The low air pressure test. Wait until your vehicle has enough air pressure, around 125 psi. Shut off the engine. Turn the electrical power on. Step on and off the brake pedal to reduce the air tank pressure. The low air pressure warning light must come on before or around 60 psi. Warning: if the warning signal doesn't work, you could lose air pressure without knowing it. This could increase the stopping distance, or your spring brakes may come on. The spring brake test. Single vehicles. To activate the spring brakes, continue to press the brake pedal to reduce the tank pressure. When the air pressure falls below 20 to 45 psi, this will cause the spring brakes to come on automatically. Tractor-trailer vehicles. The tractor protection valve and parking brake valve should close. The air pressure buildup. When the engine is at operating RPMs, the pressure should build from 85 to 100 psi within 45 seconds in dual air systems. This can take longer if the tanks are larger. In single air system, it could take 3 minutes to build from 50 to 90 psi if the engine is at idle speed between 600 and 900 RPMs. Caution: if the air pressure does not build up fast enough, it can cause your pressure to drop too low during driving. This may require you to perform an emergency stop. Parking brake test. The parking brake test is used to ensure that the vehicle will hold steady, allowing you to place a transmission in neutral or low gear without rolling or moving forward. To test the parking brake, stop the vehicle. Put the parking brake on. Gently pull against it in low gear. The service brake test. This test will help you determine if your vehicle will stop safely when you put on the brakes. Wait for normal air pressure to build up around 125 psi. Release the parking brake. Move the vehicle forward slowly, about 5 to 10 miles per hour. Apply the brakes firmly using the brake pedal. If you have brake problems, the vehicle may pull to one side. It may feel unusual, or it may have a delayed stopping action. ABS is a computerized system that keeps your wheels from locking up during hard braking applications. During an emergency, ABS will activate when the wheels are about to lock up. How to check that your vehicle is equipped with ABS. There will be a yellow malfunction lamp on the instrument panel. It will turn on and off right away. The year manufactured. If your vehicle was built in 1997 or 1998 or newer, your vehicle comes with it automatically installed. Look under the vehicle for the ECU and wheel speed sensor wires coming from the back of the brakes. If the light stays on, it may mean that your ABS may be defective. You should not worry because you still have normal braking power, but you should get this serviced as soon as possible. If your ABS malfunctions, remember to brake the same way you always have. Brake normally because you still have regular brakes. ABS does not necessarily shorten your stopping distance or guarantee that you will stop quicker, but it does help you keep the vehicle under control during hard braking. Emergency stops. If somebody suddenly pulls out in front of you, your natural response is to hit the brakes. This is a good response if there's enough space to stop and you know how to use the brakes correctly. The main objective will always be to maintain control of the vehicle. When you brake, always try to brake in a way that will keep your vehicle in a straight line. This will allow you to turn if it becomes necessary. There are two methods of braking. One method involves locking the wheels, and the other will not lock the wheels. You must determine which method will work better in certain situations. Control braking. With control braking, you will apply the brakes as hard as you can without locking the wheels. Just before the wheels lock up, release the brakes. Stab braking. With stab braking, you will apply the brakes all the way and release the brakes when the wheels lock up. As soon as they start rolling again, repeat this process. Caution. It is not recommended to use the stab braking method on vehicles that are equipped with ABS. Stopping with an air brake system is different than a hydraulic system because there is an added delay. This is called brake lag. This is the time required for the air brakes to work. Hydraulic brakes. After pushing down on the brake pedal, the brakes work instantly. This is mostly used on cars and light to medium trucks. Air brakes. With air brakes, it takes a little more time, about 1/2 second or more, for the air to flow through the lines and apply to the brakes. To calculate the total stopping distance for a vehicle with air brakes, you must take the following factors in consideration. Perception distance. This is what you see ahead. Reaction distance. This is in reaction to what you see ahead by hitting the brakes. Brake lag. This is the delay in the air brake response. And braking distance. This is the distance your vehicle will travel before coming to a complete stop. The air brake lag distance at 55 miles per hour on dry pavement adds about 32 feet to the total stopping distance if the vehicle has good traction under good road conditions. The total stopping distance can be up to 450 feet for air brake vehicles. This is equal to the length of a football field. Brake fade or failure. Brakes may fade or fail due to the following conditions. Excessive heat. If they are used too much, especially driving in mountains or hills. Not using the braking effect of the engine. Don't rely solely on your brakes. Use the engine to help slow the vehicle. The brakes are out of adjustment. From time to time, your brakes may get out of adjustment. Check them periodically. Brake drum expansion. If the brakes start to heat up, the brake drums may expand and fail. Proper braking technique. When traveling on a steep downgrade, the brakes are not the only way to slow down. By using the braking effect of the engine, you can save the brakes and avoid problems further down the road. Use the following technique. Make sure the vehicle is in the proper low gear. Apply the brakes just hard enough to feel a definite slowdown. Reduce your speed to about 5 miles below the safe speed. Then release the brakes. You can repeat this as often as necessary until you have reached the end of the downgrade.